The Archimedes screw is basically a large helix open at both ends and encased within a watertight cylinder. It operates with the cylinder somewhat tilted from vertical. When the open lower end of the cylinder is placed in water and the screw is turned, water trapped between the cylinder and the threads of the screw rises. Successive revolutions will rise the water thread by thread until it emerges at the top of the cylinder. It can be used where the water needs to be raised less than 1.5 meters, 5 feet. In such cases, it is perhaps the most efficient of the ancient methods because two men can rise an enormous volume of water in less than an hour. The Archimedes screw has been widely used over the centuries, especially to rise irrigation water and for land drainage, often being powered by people or animals. Besides being of simple construction, it has the additional advantage of being able to move water that contains mud, sand, or gravel. The Archimedes screw is still used today in some limited applications, usually electrically powered, and can range in size from a quarter of an inch to nearly 4 meters, 12 feet in diameter. A large screw or banks of screws may be used to pump rainstorm runoff or to lift water or water waste, for example. Archimedes screws, now called screw conveyors, are also used today primarily to propel dry bulk materials. However, if you do not have access to a generator pump and need a low-tech solution to rise water, it doesn't get much easier and low-tech than an Archimedes screw. The distribution today of water lifting Archimedes screw is in the Nile Delta region of Egypt. A major advantage of these pumps is variable pumping at constant speed, because the output of the design capacity is controlled by the sump level and equals the effluent flow rate. The disadvantages are the inducement of turbulency, the release of odor and other volatile substances if using for wastewater, and the relatively high initial cost if using metal components but not wooden. But when comparing costs with those of other types of pumps, consider the cost of the total system, including all piping, wet or dry wells, screens, fittings, valves, variable speed controls, and other accessories, as well as operating and maintenance costs. Note that operators like screw pumps because the good ones, when properly installed, are so trouble-free. Archimedes screws can be used to generate power if they are driven by flowing fluid instead of lifting fluid. Water transiting the screw from high to low elevation generates a torque on the helical plane surface, causing the screw to rotate. The Archimedes screw generator consists of a rotor in the shape of an Archimedean screw, which rotates in a semicircular trough. Water flows into the screw and its weight presses down onto the blades of the turbine, which in turn forces the turbine to turn. Water flows freely off the end of the screw into the river. The upper end of the screw is connected to a generator through a gearbox. The Archimedes screw is theoretically a reversible hydraulic machine, and there are examples of single installations where screws can be used alternately as pumps and generators. Pumps work by creating a vacuum in which ambient air pressure forces the liquid. All pumps work by creating areas of low pressure. In a centrifugal pump, centrifugal force accelerates the water to the outside of the impeller, creating low pressure at the eye or center of the impeller. With reciprocating pumps, the upstroke of the plunger or piston creates a vacuum. In gear pumps or lobe pumps, as the teeth or lobes mesh then come apart, a vacuum is created. The difference in pressure creates suction. A liquid under higher pressure will move to an area of lower pressure. Can you think of a way to make water run uphill without using electricity? The ancient Greeks discovered how to do just this. They developed a device called the Archimedes screw to lift water from one location to another. This tool is so useful that is still in widespread use today. In this activity, you will build your own hand-powered Archimedes screw from simple materials. Thanks for watching. Until next time.